Hey guys, this is the video for homework number 5. And the good news is that there's 3 topics, but 2 of them are definitely a review. And then one of them kind of talks about what we were doing last week with systems of equations. So I'll go over the review questions really quickly. The first one that I've listed are 5.2. This one is just finding slope or y-intercept. So basically identifying slope, which is m, and y-intercept, which is b. So remember, we're talking about y equals mx plus b, and slope is the number that's in front of x, and y-intercept is the number that's by itself. And so it's really just going to say find one of those things, and then you're given an equation, you just decide. So find the slope, so that's the number in front of x, so it's going to be a 2. So my answer for this one is 2. Easy. This one says find the slope. And so find slope, again, I'm looking for that number that's in front of x, which is 3/8. So my answer is 3/8. This one says to find the y-intercept. And I chose it specifically because, here, I'll rewrite that so I don't cover it. So if I'm trying to find the y-intercept of y equals 7x, hopefully you can say to yourself, what's happening here on the end? How come there is no number that's by itself? What is that? So really, if there's nothing there, then what you're actually saying is that you are adding 0. So your y-intercept, it exists, it's just invisible. It's invisible because it's a 0. So my y-intercept here is an invisible plus 0. This one says find the slope. And again, I chose this one because if you look in front of x, there doesn't seem to be anything. There's just x. It's a negative sign with x, right? And remember, there's always an invisible 1. So really, this is saying negative 1x plus 21 over 20. So my slope is the number in front, which is invisible because it's a 1 times x, which doesn't change it. So my slope is a negative 1. All right. The next topic is IXL topic UWB, and this is just practice graphing. So hopefully this is something we've done so much now that this seems easy, but I start with the number that's at the back, -5, mark that on my y-axis, and then my slope here is 9, which is really the same as 9 over 1. This is the part that most students mess up, is the plus 1 part. So I have a lot of students here on the plus 1 part that'll forget that, the over 1 part. So you're going up 9 and then over 1. So from here up 9 and then over 1, my next point would be. And you'll be using IXL, so it'll be easier. This one starts at a +4. And just like last time, it's just x, which means there's an invisible 1 there. So my slope is 1, but it's 1 over 1, which again, lots of students forget this over 1 part here on the bottom. So you're going up 1 over 1, which is easy because it's right through those diagonals. So it makes it easy to find when I'm drawing it, at least. All right, I think that's all you'll need for that. I feel like a lot of you are really mastering that topic. So let's move on. So the newer topic today is IXL topic AGZ. And so this is how many solutions does a system have. So a system, remember, is 2 or more equations together. And so this one is specifically talking about how many solutions does it have. That's the question that this section is kind of answering. And really, if you think about 2 lines that are together on a graph, so if I'm looking at different graphs of lines being together, there's only 3 different things that can happen when you put 2 lines on a graph. We talked about a lot of the one of them last week, which is if you put a line here and let's say the other line's here, then you end up in a situation where it crosses once. And so we say that this system has 1 solution because it crossed 1 time. And this is my solution right there. The other thing that could happen is you could place those lines in a way where you would have no solution because they would never cross, meaning that they are parallel to each other. And one of the things that you'll discover, that I'm going to write down, is that parallel lines have the same slope. So when you're looking at equations, you can tell when lines are parallel because their slope is the same. So those have no solution. So parallel lines or lines that have the same slope have no solution. And then the last option, if you think about it, you're thinking about like, I could put two lines crossing, I could put two lines not crossing. So what's the third solution? And the third solution is I can put one line in this spot, and then I'll switch colors to blue. And then let's not do blue since the graph's in blue. Let's do yellow. If I do yellow right on top of the exact same line, so I put the exact same line there, so now they are the same line, then that means they have infinite solutions, which means every solution, right? Obviously, because if you think about this, there's a whole bunch of points where they cross. So it crosses infinitely many times. No matter where I just look, it's going to cross. So those are the three things that can happen. So in this topic, AGZ, you can go through and see it's going to make you graph them. So you do have to graph them in order to answer it. It won't let you answer it right unless you make the graph. So that's good that you get to practice more graphing. On this one also, I only want you to go up to a SMART score of 50 because they get a little too complicated for where we're at right now. But if I look at this, if I graph these, so this first line, I'd start at 7. And again, it has an invisible 1. So I'm going up 1 over 1. So my line looks like this. And then hopefully, if you're paying attention, you can see that for this second one, if I go and start at 7 and go up 1 over 1, I end up on the exact same line, right? And you can see that because the equations are the same. Same equation. Which means that since these two lines are the same, every point is the same. So this is infinite solutions, which you can just see, but you do have to graph it. They're going to make you. Oh, that's not supposed to be the next screen. Let's minimize that. All right, so this was supposed to be the next one. So if I go through and graph these, so we'll do the first one. So I start at -3, and I'm going to go up 3, 1, 2, 3 over 2. So up 3 over 2, up 3 over 2, up 3 over 2, which also means I could go down 3 backwards 2, down 3 backwards 2. So these are the points that would fit in this graph here, which I like to make all the points so I can see them all. And that's what I'm drawing it. IXL does that work for you, luckily. For my blue one, I start at -4, and this time it's 2, so 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So you can see that they are obviously not the same. This looks like the same point, but it's not. This is really the same one here. So the solution is this point here. But I also just want to point out that you are supposed to graph these for IXL and then say how many solutions it has. So you don't even have to say what the solution is if it was hard for you to tell. This is one solution because it crosses at one spot. And I can tell because these are different equations. They're totally different. The slope's different. Everything's different. So they have different slopes, different numbers. I wanted to put this one on here because it has a unique equation, y equals -5. So if I do -4 and then down 1 over 6 or up 1 backwards 6, then it looks like this. And then if I do this weird looking equation here, y equals -5, this is really saying y equals 0, x minus 5. So my y-intercept is -5. And then I have a no slope, no tilt. So I'm just going to have a flat line, right? Like a flat ramp that goes through that spot. And so it's going to cross one time, right? So one solution, which makes sense because, again, these have different equations. So if they have different equations all the way around, I know it's just going to intersect in one spot. This has a similar situation, but this time it's x. So decided we should probably do a couple. This also has a -1, so don't forget that's 1 over 1. So I'd start at -2, and go down 1 over 1. This time I'm going through the diagonals, but in the negative direction. So my line, which was not drawn very well, I have a good excuse because I'm doing it on a computer. And then for the second equation, this time it's x equals -2. And this one isn't even a regular line because it doesn't have a y. So it doesn't cross the y-axis. And that's the whole thing, is it never crosses the y-axis. It crosses the x-axis at -2, but then it's parallel to the y-axis. It never crosses it, which is why it doesn't have y equals. And so really the solution would be that one place here that they cross. So again, I'm just looking for the one solution. All right, the last problem, I had to literally go through this a million times to get this to come up because it just wouldn't come up with one that had no solutions. So I wanted to graph both of these. So this is y equals x, which looks a little strange. That's really y equals 1x plus 0, if you're worried about why those numbers aren't there. And so I start at 0, and then I'm going up 1 over 1. So actually, this is like the most basic line. Starts in the middle and just goes up one box over, one box up and down. And then for the second equation, here's where finally now I can say, well, this starts at -10, which is here, but my slope is the same, right? It has the same slope. It's 1x minus 10. So these slopes are the same. And so if I go up 1 over 1, hopefully you can tell that because you have the same size staircase, the same slope, that's what's going to make it so that those lines don't ever cross. So since these have the same slope, that means they have no solution. As long as this other number is different. So it has same slope, but different y-intercepts. If it had the same y-intercepts, the exact same y-intercepts, then it would have infinite solutions, like the first one that we did, like this. So this one has the same slope and the same y-intercept. So if everything's the same, it's infinite. If the slope is the same, but the y-intercepts are different, that's when it's none. All right. Hopefully that's enough information to help you move through. Remember, you're only going up to a SMART score of 50 for this topic. And then we'll do a little bit more work on it next week and probably for practice. Okay. Let me know if you have any questions. Good luck.